Hello and welcome to this new tutorial. I'm pretty excited about this one because, as you can see by the title of the code section, we're going to get very close to the training. Because indeed, in this tutorial we're going to set up the loss error, the optimizer, and we're going to apply some gradient clipping. Gradient clipping, for those of you who don't know what that is, this is a technique, actually some operations, that will cap the gradients in the graph between a minimum value and a maximum value, and that's to avoid some exploding or vanishing gradient issues. And so we're going to make sure to avoid these issues by applying gradient clipping to our optimizer. And so we're going to define a new scope here, which will contain two elements, two final ultimate elements that we'll use for the training, which are going to be the loss error and the optimizer with gradient clipping. The loss error is going to be based on a weighted cross entropy loss error, which is the most relevant loss to use when dealing with sequences, as we are doing right now, and in general when dealing with deep NLP. And the optimizer that we're going to use will be first an Adam optimizer, which is one of the best optimizers for stochastic gradient descent, and then we will apply gradient clipping to that optimizer to avoid exploding or vanishing gradient issues. And so let's do this. Let's define the scope. You already know how to define a scope. We did that for the decoding scope. So we need to take our TensorFlow library and then the name scope function to which we need to input the name of the scope in quotes. And we're going to choose the name optimization. All right, that's our optimization scope. And inside the scope, we're going to set up these two essential tools for the training, that is the loss error and the optimizer with gradient clipping applied. So let's start with the loss error. We're going to introduce a new variable, loss error, and that we will get it thanks to the sequence loss function by TensorFlow. So let's get this module, tf, then we get it from contrib, and then there we go, we get our sec2sec module from which we will get the sequence loss function. All right, so the sequence loss function, and that's going to take several arguments. The first two arguments, as usual when dealing with the loss function, is going to be first the predictions and the target. And since right now we're preparing the training, these are going to be our training predictions that we just got in the previous tutorial. So training predictions first, and then the second argument is of course going to be the target. And I'm going to put them right below so that you can see them better. The target, and that's of course because we're going to measure the loss error between the training predictions and the targets. All right, so that's the two most essential arguments. But then we have some new arguments which will correspond to the weights. And so we have to prepare this tensor of weights, initialize them all to 1, and of course with the right dimensions. So to initialize the weight as a tensor of 1, well, we're going to use the TensorFlow library and then one of its function, very useful function for that, which is the ones function. The ones function that takes only one argument that we have to input in square brackets, and that's of course the shape, as we can see it here. The other ones are optional. That's of course the shape of this tensor. That is the dimensions of this tensor. And so we're going to enter first the number of lines and then the number of columns. So let's start with the number of lines. The number of lines of this tensor should be our input shape of index 0. That's the first dimension. And then the second dimension is going to be the sequence length. And that's perfect. We already got previously the input shape right here when getting the shape of the input tensor, and we got the sequence length just before. All right. And that should be the dimensions of this tensor of weights, all initialized to 1. Perfect. That gives us the loss error. So that's our first essential tool for the training. And now we're going to prepare the second essential tool, which is the optimizer. And so we're going to do that in 3 steps. First, we'll get the Adam optimizer, which will be an object of the Adam optimizer class. Then, second step, we will prepare gradient clipping. That is, we will cap our gradients between the minimum value and the maximum value. And then eventually we will apply gradient clipping to our optimizer. All right, so let's start with the first step. The first step is to get the Adam optimizer. And therefore, I'm introducing a new variable here, optimizer. And this optimizer is going to be an object of the Atom Optimizer class, which is a class by TensorFlow and taken from the module train. All right, train, from which we get the Atom Optimizer, which is right here, Atom Optimizer. And this Atom Optimizer, as every optimizer class, takes one fundamental element, which is the learning rate. The learning rate that we already prepared before in the hyperparameters right here, learning rate equals 0.01. We're starting with this value, and if this doesn't work well, we will tweak some other values. So let's input the learning rate inside the arguments of our optimizer, learning rate, and there we go, we have our optimizer. And now, next step. Next step, as I said, is to clip all our gradients. You know, we have one gradient per neuron in the neural networks, and for each of these neurons, we compute the gradient of the loss error with respect to the weight of that neuron. And all these gradients are into a graph and are attached to a variable. All right? So now the first thing that we need to do is compute all these gradients, and to compute them, that's where our optimizer comes in. We're going to use a method from that optimizer, which is the compute gradients method, and that will compute these gradients of the loss error with respect to the weights of each of the neurons. So let's get them. Let's get our gradients, just introducing a new variable here, gradients, and we're going to get them, as we said, thanks to our optimizer, from which we apply the compute gradients function. And this compute gradient function takes one essential argument, which is the loss error of which we want to compute the gradients with respect to the weight, and computing a gradient is always with respect to the weight, so we don't have to input the weights as argument, but just the loss error of which we want to compute the gradient, and therefore I'm entering here this loss error which we got in the previous step, loss error here. So that computes all the gradients of the graph, and now let's cap each one of these gradients. And so I'm going to introduce a new variable that I'm going to call clipped gradients that are going to be our gradients clipped by value. And to show you what this means, I'm going to walk you through the TensorFlow documentation right now to show you 2 pages, gradient clipping, that I will share with you in the resources of this lecture, and that explains to you what gradient clipping is in more details, and this clip by value function that we're about to use to clip our gradients. So as you can see, this function takes 3 arguments. The first one is the tensor of gradient, that is each of the tensor of gradient among all the gradients in the graph. Then the second argument is the minimum value below which the gradient's value cannot go. And the third argument is the maximum value above which the gradient's value cannot go. We'll choose the minimum to be -5 and the maximum to be 5, and that will clip our gradients in a way to avoid vanishing or exploding gradient issues. So let's do this. Let's go back to Python and let's clip all our gradients. So clipped gradients equals, and now, since we want to do that for each of the gradients of the graph, we're going to have to make a for loop, to loop over each one of these gradients. And as I said, a gradient in the graph is attached to a variable. And therefore, we're going to have 2 loop variables, the gradient tensor itself and the variable attached to it. And we're not going to make a for loop as we did before. We are going to make this for loop into some square brackets, which is a trick, a technique to get these gradients directly inside a list. And therefore, as we said, we're going to start a for loop. We're going to loop over the 2 elements of each of the gradients in the graph, which are first the gradient tensor, which I'm calling the grad tensor, and its variable that I'm calling the grad variable. So grad tensor, grad variable, which basically means for each gradient in all our gradients that we got in the previous line. Those gradients here that we computed thanks to the compute gradient function, thanks to our optimizer. So for each of these gradients among all the gradients, well, we're going to do something, but before we do that, we have to add some safety here to make sure that the tensor of the gradient is existing. And therefore I'm adding if the grad tensor is not none. That is, if it is existing. So now we have the loop, perfect. We make sure that the gradient tensor is existing, and therefore let's specify what we want to do for each of these gradients, and we have to specify this before the loop, and that's where we use the clip by value function to clip each one of our gradient tensor. But to keep track of each gradient, we're going to form a couple here, and this couple will actually be the gradient as a whole in the graph, which is composed of two elements, the gradient tensor and the variable. And therefore, in this couple of parentheses here, I'm going to introduce first the tensor that we're going to clip thanks to the clip by value function, and then the variable, which is the other loop variable in our loop. So first, let's get the first element of the gradient as a whole, which is the grad tensor, and that we want to clip by value, applying the clip by value function that we take from TensorFlow, of course. tf.clipByValue, that will clip by value this grad tensor from, as we said, -5 to +5. And it's better to use floats here, so I'm adding a dot, a decimal, from -5.0 to +5.0. And this clips the tensor of the gradient we're dealing with right now in the loop, but which will be done for all the grad tensors of the gradients in the graph. All right, and now the second element of the gradient is its variable that we called grad variable, and therefore I'm including this second element here, grad variable. All right, so basically in this loop here, we're just clipping the tensors of each of the gradients in the graph that we computed before, thanks to the compute gradients method of our optimizer. All right, so great. So now we have our clipped gradients, and we have one final step to do, which is to apply gradient clipping to our optimizer. So let's do this. Let's get our new optimizer that we're going to call optimizer gradient clipping, which exactly is the optimizer on which gradient clipping was applied. And to apply it, well, we need to take our previous optimizer, the Atom Optimizer object that we created from the Atom Optimizer class, and then from this object we're going to apply one of the methods of the Atom Optimizer class, which is this one, apply gradients, and of course this is going to take one argument, which are going to be the new gradients that we got and that we clipped in the previous line. And therefore I'm entering here our clipped gradients. Perfect. We just set up the loss error, the optimizer, and gradient clipping, and that's a very good thing done for the training. So now we have a few steps left to do before the training, and in 2 or 3 tutorials we'll start the big for loop of the training. So now I'm going to leave you with this code section that I'm going to execute, and until then, enjoy the NLP. Hello and welcome to this new tutorial. Now we're going to finally apply the padding to the sequences with the pad token. So first, we'll answer 2 questions. First, why do we have to do that? And second, what are we going to do exactly with our questions and our answers? So the answer to why we have to do this is that all the sentences in a batch, whether they are questions or answers, must have the same length. And now the second question, what are we going to do exactly? Well, as you can see, I've prepared here 2 sentences, 1 question and 1 answer. And as you can see, the question, who are you, and the answer, I am a bot, with a dot, don't have the same length. And after we apply the padding, this question and the answer will become this. Who are you, pad, 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 and I am a bot, EOS pad. So basically, the pad tokens are added so that the length of the question sequence is equal to the length of the answer sequence. So that's the purpose of padding, and that's a must-do in Deep NLP. So now what we're going to have to do is, for each batch and for each sentence of each batch, we will complete the length of each sentence with enough pad tokens so that each sentence of the batch has the same length. So let's do this. It's going to be quite easy. We're actually going to make a function that we're going to call apply padding. Apply padding function that is going to take 2 arguments. The first one is the batch of sequences, we can call it this way, batch of sequences. I just want to make sure you understand the argument here. That's a batch of sequences and not single sequences. So batch of sequences, first argument, and the second argument is going to be a word to int dictionary, whether it is the questions word to int dictionary or the answers word to int dictionary. We will actually use them both, but the name of the argument I'm giving here is word to int. Just keep in mind that it is the dictionary mapping the words to the integers. Alright, so that's our two arguments, and now let's define what this apply padding function has to do. So you get what this has to do. It has to complete the sentences with pad tokens so that all the sentences in the batch have the same length. You can actually practice, do a little exercise here and try to make that function. You take your batch of sequences, you take each sequence of the batch, and you try to add the pad tokens in a way that all the sequences of the batch have the same length. Alright, and now I'm going to start implementing the solution. So, since all the sequences in a batch must have the same length, we're going to start from the sequence in the batch that has the maximum length. And then what we'll do is we'll take all the other ones and we will complete them with pad tokens so that all these other ones have the same length as the largest one, as the one with the maximum length. So let's do this. Let's get this largest sequence, and more specifically what we need exactly is the length of this largest sequence, because we will use this length to complete the other shorter sequences in the batch. So I'm going to introduce a new variable here that I'm going to call max sequence length. Alright, the maximum length of all the sequences in the batch, max sequence length. And how are we going to get it? Well, we'll basically take the list of all the sequences and get the max of the length of these sequences. And there is actually a trick to do this in one line of code. You might guess what it is. It's the for loop inside the list. And you know, we take the maximum of the length inside this list that we have to put in square brackets. And there goes the for loop inside. And so now what do we want to get? We want to get the max of the sequences in the batch. So we're going to have to loop over all the sequences in the batch. And to do that, we do for sequences in, well, our argument, batch of sequences. So I'm just copying this in batch of sequences. And what do we want exactly among all these sequences that we managed to get thanks to this loop? Well, we want the length of the sequence. All right, and thanks to the max here, we'll get the maximum of the sequence length. All right, perfect. So now we have the largest sequence length, and we'll use that right now to complete the other sequences, which are shorter, with pad tokens. So I'm going to introduce a new line here, and that's where we'll complete the other sequences. So how are we going to complete them? Well, first of all, since that's exactly what we want to return, you know, the batch of sequences completed by the pad tokens, we are ready first to return what we want. And what will come after the return is the batch of sequences with the added pad tokens. So how are we going to add these pad tokens? Well, first of all, we have to return the list of sequences. So I'm introducing some square brackets here. And then we're going to do the same trick, a for loop inside this list, because of course we have to loop over again all the sequences, because for each of these sequences, we are going to add the pad tokens to make them have an equal length to the largest one. All right, so for, then sequence again, in, of course, again, our batch of sequences. I copied that before. And so that's the for loop, and what we want to do comes before the for loop. And what we must do is add the tokens to complete each of these sequences. And how are we going to do that? Well, the trick is to first take our sequence, which so far has a not long enough length, but we're going to add the pad tokens to that list. The sequence right now is a list of token key identifiers. And so what we're going to do is a list addition. We're going to add up two lists, and the first list will be the sequence, and the second list will be a list of pad tokens of length that will complete the length of this new sequence we want to get so that it has an equal length as the largest sequence. And the trick to do that is to add here plus. Then, since we're adding up two lists, I'm introducing some square brackets here. And inside these square brackets, we're going to have the right number of pad tokens so that our sequence gets the maximum length sequence. And to do that, what we're going to do is, well, first get our pad token, but we need to actually get the integer ID of the path token, because remember, our sequences are encoded into unique integers, and therefore that's where our word-to-in dictionary comes into play. We're gonna get it to get this unique integer ID encoding the path token. So I'm taking my word-to-in dictionary, and then in square brackets, well, since the key of that dictionary is the token itself, I just need to enter the token in quotes. And so, well, we can get it here. That's of course the pad token, which I'm copying here as the key of my word-to-in dictionary. That will return the unique integer ID of the pad token. All right, and then that's not over, of course. To complete the sequence so that it has the maximum length sequence, we're going to multiply this single element list that contains the pad token ID by a scalar, that is by an integer, which will be, wait for it, the maximum length sequence minus the length of that sequence. And that will complete this sequence so that it gets the maximum length sequence with the pad tokens that complete it. Alright, so multiplying this single element list by a scalar is like doing a list addition several times so that it gets several pad tokens inside this list. Alright, so as we just said, we have to multiply this by the difference between the max sequence length, which we got at the previous line, so the max sequence length, minus the length of that sequence, so that we can complete it with the pad token IDs. And so now very easy to get this length of the sequence we're dealing with right now in the loop. Well, we have to get the len function of the sequence. And that will complete the sequence so that it has the maximum length sequence, that is, so that it has the same length as the sequence that has the largest length. All right, I'm just removing that s here because that was the loop variable, which doesn't take an s. And here, everything looks great. We're ready to execute this to define the apply padding function. And there we go. We now have our function, apply padding, and we will definitely apply it very soon on our batch of sequences. Until then, enjoy DeepNLP. Hello and welcome to this new tutorial. I'm super excited because we are 2 steps left from the big training. And the 2 remaining steps that we have to do is first split the data into batches of questions and answers, and that's what we'll do in this tutorial. And then the second step is to split, again, the questions and answers into training and validation data, because we will do some cross-validation during the training to keep track of the predictive power on new predictions, which will be 10 or 15% of the training data. All right, so let's take care of this first step in this tutorial, which is to split the data into batches of questions and answers. That's a fundamental thing to do in deep learning, to work with batches, and basically in this tutorial we're going to make the batches. All right, so we're going to do that into a new function that will use the previous function because, of course, inside each of these batches we will pad the questions with the pad tokens. So we will make a new function, and then, of course, in the training we will apply that function to create the batches and feed the neural network with these batches of inputs and targets. I remind that the inputs will correspond to the questions and the targets will correspond to the answers. All right, so let's do this. Let's make this function. We start with def, and this function is going to be called split into batches. I think that's clear this way. Split into batches, and you can naturally guess the arguments that this function is going to take. Well, that's going to be, of course, first our questions, then our answers, and finally, of course, the inevitable batch size, because we have to choose a batch size for our batches. So split into batches, questions, answers, batch size. Then colon, and let's go inside the function. All right, so we have to create several batches depending on the total length of the questions, that is the total number of questions, and therefore we will have to figure out this total number of batches we have to create, which is a simple mathematical formula. And then once we figure out this number, we can start a for loop to loop over each one of these batches, and then inside these batches we will get the batch of questions, which will be our batch of inputs, and then the batch of answers, which will be our batch of targets. And of course, inside of each of these batches, we will apply the apply padding function to make sure that the sequences in our batches, whether they are questions or answers, will be padded with the pad token so that they all have the same length. So let's do this. Let's start with this for loop. And so we have to loop over, well, let's say we're going to loop over some batch indexes. So for batch index, that's how we'll keep track of the batch. So for batch index in range, it's going to start from 0. The first batch will have index 0. Naturally, with Python, indexes start at 0. From 0 to, and that's where we need to figure out the number of batches we'll have in the end, which depends on two things. First, the total number of questions, which is also the total number of answers, because for each question we have its answer. And the second element on which it depends is the batch size, of course. And so the number is naturally the total number of questions divided by the batch size. That will give us the number of batches we have to create, because basically this will split the data into batches of size, batch size. All right, so let's do this. It is from 0 up to the number of questions which I can get thanks to the len function that I apply to the questions. So that gives me the number of questions and also the number of answers. But we need to divide that by the batch size. But in order to get an integer, we're going to use this, double slash, and that divides the len questions by batch size. All right, so this len questions divided by batch size, we are ready to start the for loop. All right, so we're going to start with a start index. This start index will be the first index of the question we are adding in the batch. You know, we're dealing with a specific batch right now that has a specific batch index, but this start index here is the index of the first question we are adding to this batch, and therefore also the index of the first answer we are adding to this batch. So start index, and how can we get it at a specific step in the loop? Well, that's going to be equal to our batch index multiplied by the batch size. All right, let's explain that with the first indexes. So we start at batch index 0, right? That's our first batch. And therefore the first question we'll add is the first question, the very first question of all the questions, and it will have the index 0, batch index times batch size. So that will be the start index of the first question we'll add in the batch. And then when batch index equals 1, which is the next step in the loop, well, that's where we'll deal with the second batch with index 1, and therefore the index of the first question we'll add to this second batch will have to be the batch index 1 times the batch size, which is, for example, 64. We chose 64. This first question we'll add to this second batch will have to be the next questions after all the questions we added into the first batch. And therefore, since there were 64 questions in the first batch, well, the index of these first questions we're adding to the second batch must be 64, because the questions in the first batch had index from 0 up to 63. So that's how it works, and that's how we can get the start index, that is the index of the first question we are adding to the batch we're dealing with at each step of this iteration. So start index equals batch index times batch size, and now we are ready to add our questions in the batch and our answers in the batch, because basically we just needed this start index. So first, let's get our questions in the batch. So I'm calling this variable questions in batch. I think that's pretty clear. These will be the questions we add to this specific batch we are dealing right now in the loop. So questions in batch equals, and now very simply we need to take our questions, our whole list of questions, and just get the right indexes of these questions that have to go into the batch we're dealing with right now in the loop. And that we can get thanks to this start index and of course the batch size, because these questions that we want to add right now have their indexes starting from start index up to start index plus batch size. And there we go, we have our questions in batch. Alright, perfect. And now let's take care of our answers. Answers in the batch. We're basically going to add the answers to those previous questions here in the batch to this same batch we're dealing with right now in the loop. And so I'm going to call this new variable answers in batch, which same will contain the answers in this batch. And therefore, that's going to be exactly the same here. We just need to copy this and just below paste it and replace questions by answers. All right, and that gives us the answers to those previous questions in the batch. Great, and now what do we have to do? Well, that's very simple. We just need to apply padding to each of the questions we added in this batch and also each of the answers we added in this batch. And that's why we had to do this apply padding function before, because basically now what we're going to do is apply the apply padding function to each of the questions in our questions in batch and each of the answers in our answers in batch. And so I'm going to introduce two new variables. First, padded questions in batch and padded answers in batch. All right, padded questions in batch and padded answers in batch, which will contain the same questions and same answers in the same batch, but with the padding applied, with all the pad tokens. And so to apply this, well, we simply need to take our apply padding function, which I'm copying here and pasting it here, and same here as well, apply padding. And inside, what do we need to do? Well, as you can see, the apply padding function takes two arguments. First, the batch of sequences, which is exactly this batch we're dealing with right now. So for the questions, it's going to be the questions in batch, and for the answers, it's going to be the answers in batch. And then the second argument, let's not forget it, it's our word to int dictionary. And so you know what dictionaries will take for respectively the questions and the answers. For the questions, we'll take the questions words to int dictionary, and for the answers, we'll take the answers words to int dictionary. And there we go, we will have applied padding to both our questions and our answers in this specific batch we're dealing right now at the loop. So right, let's do this. Apply padding to our, well, let's copy this. That's to our questions in batch. So questions in batch and with the questions words to int dictionary. All right, and then same for our answers. We're going to apply that to our answers in batch, pasting that here with our answers words to int dictionary. And there we go. That applies the padding to all the questions and all the answers in the batch. But now we're just going to add one more thing to this data structure we just got. This data structure is actually a list. You know, we returned our padded functions in a list of sequences, but we actually need a numpy array. Because then when working with TensorFlow, we need to start with a numpy array. So what we simply need to add here, which will englobe all this apply padding of the questions and the answers, we simply need to add the numpy array function, which we need to apply to the whole thing here. And same here, I'm taking numpy that has a shortcut np and the array function, there we go, that takes the whole padded answers in batch here. All right, and that's okay. Now we have our batch of padded questions and our same batch of padded answers in numpy arrays, which will be ready to transfer soon to TensorFlow. All right, and finally we have to return our padded questions in batch and our padded answers in batch for each of the batch, so we have to stay in the loop. But this time, to do this, we're not going to use the return syntax, we're going to use the yield syntax. The yield in Python is like a return, but it's better to use it when dealing with sequences. I will provide in the resources of this tutorial a nice explanation of the differences between return and yield. All right, so yield, and we want to return our padded questions in batch and also our padded answers in batch. And there we go, we're done with our split into batches function. So now we're going to select all this code section and execute to get our split into batches function. All right, amazing. we are now one step left from the big step of the training. We have another split to make, which is to split the questions and the answers into training and validating data. We'll do that in the next tutorial, and then eventually we'll get to the training. Until then, enjoy Deep NLP. Hi guys, welcome to this tutorial, and let's do the final step before the big training step. That is before the big training for loop. So this final step is to split the questions and the answers into the training and validation sets. So I'm saying sets because we're going to make basically a set for the training questions, a set for the training answers, then a set for the validation questions, and a set for the validation answers. And for those of you who see cross-validation for the first time, well, I remind that it is a technique that consists of, during the training, keeping 10 or 15% of the training data aside, which won't be used to train the neural network, that is, which won't be basically back-propagated, and just to keep track of the predictive power of the model on these observations that are like new observations. So basically, we're just testing the model on the side, but during the training, just to keep track of what it's capable to do on new observations. And so this validation set that we have to make for both the questions and the answers is exactly this 10 or 15% of the data on the side. So let's apply cross-validation, and that consists exactly of splitting the questions and the answers into 4 sets, the training and validation sets. So let's do it. The first step we need to do is to get the index that will separate the first 50% questions of all our questions and the next 85% of questions of all our questions. So basically, we're finding the index that will split the first 15% questions and the last questions. And we're going to call this index training validation split. All right. And how are we going to get this index? Well, that's pretty simple. First, this index is an integer, so I'm going to use the int function to make sure we have an integer. And then inside this function, we'll basically do a simple operation that will basically multiply the total number of questions we have by 15%. But then we'll probably get a float, and that's why we have to use this int function to make sure we have an integer, because an index is always an integer. All right, so let's make that simple operation. We need to take the total number of questions we have, and actually we're going to use our sorted clean questions list we made in part 1 data preprocessing. Remember, that was the last step of the preparation of our questions. That was the last update of the questions. So basically, these are all the questions, all cleaned and sorted by the length of the questions and gathered into sequences of unique encoding integers. And so we're going to use this, which contains the whole list of encoded questions. We're going to use this to get the total number of questions that we're going to multiply by 15% so that we get this index of the split between the validation set and the training set. All right, so let's get this, the total number of elements in sorted clean questions, which we can get by taking the len function of these sorted clean questions. All right, so that's the total number of questions, basically, and this we are going to multiply by 15%, that is 0.15. All right, and that will give us the index, splitting the first 15% of the questions and the last 85% of the questions. All right, and now that we have this index, well, this is going to be very easy. We'll get our training questions, our training answers, our validation questions, and our validation answers. And to get them, we'll take, of course, our sorted and clean questions. For the training set, we'll go from this training validation split index up to the end. And for the validation set, we'll go from the beginning up to this training validation split index. And then to get the training and validation answers, we'll take the sorted and clean answers list. And to get the training answers, well, same, we'll take all the answers from this index up to the end. And to get the validation answers, we'll take all the answers from the beginning up to this index. So let's do it. Let's start with our training questions. Training questions. And so now we're going to take our sorted clean questions. And to get what we want, well, what we need to get exactly is the 85% last questions of this whole list of sorted clean questions. And to get this, we need to get all the indexes from the training validation split index, so I'm copying that here, up to the end. And the trick to take it up to the end is just to add this colon here and then nothing. That will take all the questions from this index up to the end in the whole list of sorted clean questions. All right, and now I'm going to copy this because the rest is going to be quite the same. Then we're going to get the training answers. Therefore, I'm replacing here questions by answers. All right, and then same here as well. We're going to get our training answers from the sorted clean answers, whole list of answers. And same to get the training answers, we're taking all the answers in the sorted clean answers list from the training validation split index up to the end. All right, and now I'm going to copy these two lines because we're going to do the same for our validation questions and our validation answers. And so we'll just have a few things to replace here. First, training by validation. Same here, training by validation. And then here we keep the sorted clean questions and the sorted clean answers because basically we just have to take some other indexes, which are the complementary indexes, starting from the beginning. Therefore, I'm cutting this up to, well, this same training validation split index. And since our validation questions are from the beginning up to the 15% questions, well, we have to go from the beginning up to this training validation split index. And therefore, what I'm going to do now is just copy this because it's going to be the same for our answers. We, of course, need to keep the right answers aligned with their questions. Otherwise, the dataset will not make any sense. And there we go. Now we have our training questions, our training answers, our validation questions, and our validation answers. And so that's wonderful because basically, there you go. We are ready to start the big training for loop. I'm super excited to start, but I'll have to take a nap because I'm going to need a lot of energy for this and also some chocolate. But as soon as I get that, I will start recording the biggest tutorial of this course, which is the training. I can't wait to start. I'm going to select this and execute. And now we have our training questions, training answers, validation questions, validation answers. So we're more than ready to start the training. Until then, enjoy Deep NLP. 3, 2, 1, go. Let's start the training. So we're going to start by introducing the batch index check training loss that we're going to set equal to 100. And that's because we will check the training loss every 100 batches. So you'll see how we'll use it later. Then I'm going to copy this variable because the second variable we will introduce is going to be the batch index check validation loss. And that, the validation loss, we will check it halfway and at the end of an epoch. And therefore, since the middle of an epoch corresponds to half of the number of batches, I'm going to get this half of the number of batches by taking all our questions, that is the total number of our questions, so len training questions, that I'm going to divide by the batch size to get the total number of batches, and then I'm going to divide by 2 to get half of this number of batches. And then I just need to use a -1 just to round it down. Then I'm going to introduce the total training loss error. And I'm going to initialize it to 0. And that will be used to compute the sum of the training losses on 100 batches. Because we chose to check the loss every 100 batches. All right. And then I'm going to copy this because the next variable that I'm going to introduce is first not a total loss error, but a list of loss errors, and not of the training, but the validation. So that's going to be the list of the validation loss errors. And why do we have to make a list? That's because we're going to use the early stopping technique, which consists of checking if we manage to reach a loss that is below the minimum of all the losses we got. And all the losses we get, we're going to put them in that list. All right, and I'm going to initialize this as an empty list. Then, speaking of early stopping, I'm introducing early stopping, and I'm going to introduce two early stopping variables. The first one is going to be early stopping check. That is going to be 0, and that is going to correspond to the number of checks each time there is no improvement of the validation loss. So each time we don't reduce the validation loss, early stopping check is going to be incremented by 1. And once it reaches a certain number, which is going to be our next variable here, well, we will stop everything. We will stop the training. And that number from which we're going to stop, we're going to call it early stopping stop. And that is going to be equal to 1000. So 1000 is a bit high, but that's just because I want to make the training last until the last epoch, that is 100. But if you want to really apply early stopping, I would recommend to choose rather 100. All right, and then we're going to get our checkpoint. That's just to save the weights, which we will be able to load whenever we want to chat with our trained chatbot. So I'm going to put them in quotes, and I'm going to call them chatbot underscore weights.ckpt. All right, so that's going to be the file containing the weights. Then we're going to run our session by taking our session object and then using the run method. And inside this run method, we have to initialize all the global variables by taking first the TensorFlow libraries and then taking the global variables initializer function like that. Okay, so far? Perfect. Next step. The next step is to start the big for loop, this huge for loop that is going to do all the training. So for, it's going to be, of course, a for loop over the epoch. So for epoch in range, and we're going to start from 1 up to the total number of epochs we chose in the hyperparameters, and that was given by the variables epochs. Only because the upper bound in a range is excluded, we want to add a +1 here. All right, and now let's go inside this for loop. And there goes already a second for loop, because of course, in each epoch, we have to loop over all the batches, because I remind that an epoch is completed when all the batches go back and forth the double recurrent neural networks in our sec-to-sec model. So for, and now we're going to use the split into batches function that we made in the previous code section to get the batch indexes, that is the index of the batch, and then for each of these batches, well, we're going to get the padded questions in the batch and the padded answers in the batch. And therefore, my loop variables are going to be here. First, batch index, and then in a couple, my padded questions in the batch and my padded answers in the batch. And all of them, we're going to get it thanks to first the enumerate function, because the split into batches function returns several elements. And now that's when we get our split into batches function that, remember, takes 3 arguments. First, our training questions, the input, then our training answers, the target, and then the batch size. All right, and that will give us what we want, that is the loop variables. Perfect, then colon and next step. The next step is to get the starting time, that is, we're going to measure the time of the training of each batch, and therefore we're going to get the starting time here thanks to first the time library and then the time function. All right, and then we'll get an ending time, and we'll do the difference between the ending time and the starting time to get the time of the batch. Then, next step is to get the training loss error of this specific batch we're dealing with right now. And to get this batch training loss error, we're going to run our session with our optimizer and the loss error that we'll put into a list, and the inputs, the targets, the learning rate, the sequence length, and the key probability, well, basically everything that we need to get the training loss error, as we defined in the previous code section, to get the training loss error on this batch. And since this run method by the session object is going to return 2 elements, and since actually the batch training loss error corresponds to the second element, we have to start with an underscore here to say that we don't want the first element returned, but only the second one, which is the one we want, and that is batch training loss error. All right, and that's where our session comes into play. From this session, we're going to take the run method, and first we need to get in a list our optimizer with gradient clipping applied, and of course the loss error. And then in the dictionary we'll get first the input, which are of course our padded questions in batch. Then we're going to get our targets, which are of course our padded answers in batch. Then the learning rate, LR, and remember the hyperparameters learning rate. Then the next one is the sequence length, and that we can get it by taking the padded answers in batch, the batch we're dealing with right now, and then taking the shape of index 1 of these padded answers in batch, and that gives us the sequence length. We already covered that in one of the code sections before. Then last one, the keep prob parameter, that, remember, in the hyperparameters we took keep underscore probability, which is equal to 50%. Great. So then, now that we've just got our batch training loss error, well, we're going to add it to the total training loss error, because then we want to get the total training loss error on 100 batches, and then we'll do an average. And therefore, what I'm going to do now, I'm going to take this total training loss error that I'm copying, pasting it here, and adding to it the batch training loss error. So I'm copying this and pasting that here. All right, perfect. Then next step. So the next step is simple. It's just to get the ending time, which we can get just by measuring the time again with the time function by the time library. And then next step is to get the training time of this batch, which is, well, let's call it batch time, which is equal to the ending time minus the starting time. All right, so that will give us the time of the training of this batch, this specific batch we're dealing with right now in the loop, the second for loop. And now we're going to compute the average of the training loss errors on 100 batches, and we will print that error to keep track of the training loss errors. All right, so to get these 100 batches, we're going to do that with an if condition that will check if the batch index is divisible by, well, the batch index check training loss, that is 100. So if it is divisible by 100, which we can check by seeing if the rest of the division of batch index by batch index check training loss is equal to 0, then that means that we would reach 100 batches or 200 batches or 300. That's basically every 100 batches. And so if that's the case, we're going to print the epoch, the batch, the average training loss error on 100 batches, and the training time on these same 100 batches. So let's do this. Let's make this print quickly. So we have to put double quotes first. First, we're going to print the epoch, and that's going to be with 3 figures over the total number of epoch that we have to put in brackets. I'm going to give you some documentation on this syntax I'm using. Don't worry about this. Then we're going to print the batch we reached, the batch index. And since we have a lot of batches, we're going to use, well, this time 4 figures over, again, the total number of batches. Then the training loss error, of course. And this time we're going to have some decimals and a lot of figures. So let's put 6 figures with 3 decimal, and that's a float. And also we can add the training time on 100 batches to be specific. And that will be an integer, so colon D. And we can add then seconds to specify that it's measured in seconds. All right, and then we need to add all our variables in format. And so first we wanted the epoch reached. Then we need to print the total number of epochs, which we get thanks to our variable epochs with an S. Then we need the batch index. Then the total number of batches, which we can get by dividing the total number of training questions by the batch size. Then finally, what's most interesting, the average of the training loss errors on these 100 batches, and that we can get by dividing the total training loss error by the batch index check training loss, which is equal to 100. And finally, the training time of these 100 batches, which we can get by taking first the int function to make sure we get an integer number of seconds. So int batch time times, well, this same batch index check training loss, which is equal to 100. And that gives us the training time of 100 batches. Perfect. We're done with the printing. Now, next step. The next step is, well, first to make sure we're still in the if. That's the case. Perfect. And to reinitialize the total training loss error to 0, because that was just to compute the total training loss error of 100 batches, and we were done dealing with these 100 batches, so we're going to have to do the same thing for the next 100 batches. All right? Then, the next step is first get out of this if condition and do a new if condition to this time take care of the validation set. So we're going to do the same. We're going to compute an average of some validation loss errors, but on the validation set. And so the first thing we're going to do is an if condition, because remember, we want to check the validation loss error halfway and at the end of an epoch. And therefore, to do this, we're going to check if our batch index that we have reached so far is divisible by, this time, the batch index check validation loss, which is equal to half of the total number of batches. And therefore, I'm pasting that here, and I'm checking if this is equal to 0. But then we don't want to include the first batch, so I'm excluding it by checking if the batch index is larger than 0. All right, so if that's the case, what are we going to do? Well, first we're going to initialize the total validation loss error to 0, exactly as we did before with the total training loss error. Then we're going to get a starting time, because we're going to measure the time of each batch again. So starting time that we get thanks to our time library and then the time function. Then what we're going to do is a new for loop, still in this if condition, that is actually going to be the same for loop as what we did here, but of course replacing all the training by validation. So let's copy this second for loop. That's quite dangerous to do it, but we'll manage. Let's copy it and let's paste it here just below starting time. All right, and now let's make the required changes. So first of all, we're going to give a different name to that loop variable, batch index, to specify that this time it's going to be the index of a batch in the validation set. So I'm specifying here batch index validation. Then still we're going to get our padded questions in the batch, padded answers in the batch, and that we're going to get thanks to the split into batches function. But that this time is going to take as arguments not the training questions and the training answers, but the validation questions and of course the validation answers. So validation questions, validation answers, and the same batch size, of course. Then let's go back. Then since we already introduced here the training time, we don't need that. I'm removing this line. And then a very important thing to change here. When we run our session here, well, since we're not doing some training here with the validation, because the validation consists of just testing your model on new observations which won't be used for the training, well, for that reason, we don't need the optimizer. The optimizer is only used to compute the gradients and therefore only used for the training. So I'm removing this and also these square brackets here. We don't need them. We just need the loss error. And then since we removed the optimizer, well, this run method is going to return just one argument, which will be the batch, not training, but validation loss error. And therefore, I'm removing this underscore because it only returns one argument. Great. Then we need to align things here. for the target, then the learning rate, then the sequence length, and keep probability. But there, does that ring the alarm? Well, the keep probability is only used for the training because that's used to activate the neuron with a certain probability, which we chose to be 50%. But here we're dealing with the validation set, and therefore the probability is always 1 because the neurons always have to be present. Deactivating them with a probability of 50% is just to improve the training. And therefore, instead of keep probability here, I'm going to put 1. All right? And that's it. That was the only replacement we had to make here. All right. Then we add the batch, not training, but validation loss error to our total, not training loss error, but validation loss error. And then we get the ending time, but it has to go outside of the loop because we started the time before the loop, and therefore same for the batch time, which is equal to the ending time minus the starting time. Perfect. We are done with this second for loop, and therefore we are ready to compute the average of these validation losses. And that's exactly what we're going to do now. And to compute it, we're going to introduce first a new variable that I'm going to call average validation loss error. That is going to be equal, of course, to the total validation loss error divided by the number of batches in the validation set of our questions. And therefore, I'm taking here the length of the validation questions divided by the batch size. And that gives me exactly the number of batches in the validation set. All right? And therefore, I get the average validation loss error, which is exactly what I want to print right now at this stage of the loop. And therefore, we're going to do a quick print again. We're going to print, in quotes, the validation loss error. Going to scroll down a bit. Validation loss error, that will be a float that we have to put in brackets with, let's say, 6 figures and 3 decimals, and F to specify it's a float. Then we're going to print also the batch validation time, and that will be an integer colon D. And then we can specify seconds again. And then in the format function, we need to enter these variables. So the first one is what we just computed here, that is the average validation loss error. That's what we'll get in these brackets here. So that's the first one. And the second one is going to be simply the batch time that I make sure to be an int, an integer. All right, perfect. Next step. The next step is to apply early stopping, but we'll do a small break here and we'll do that in the next tutorial. Until then, enjoy Deep NLP. Hello and welcome to this new tutorial and welcome back to the training. All right, so we made some good progress here, and the next step is to apply some decay to the learning rate. And that will be thanks to our learning rate decay. And therefore, to do that, I'm taking my learning rate, and since the decay consists of multiplying the learning rate by the learning rate decay to reduce it by the decay rate, well, I'm going to multiply this learning rate by our learning rate decay. And so now, remember that we want to have a minimum learning rate, and therefore to make sure of that, we're going to add here the if condition to check if our learning rate that was reduced by the decay is lower than this minimum learning rate. And if that's the case, if it was decayed, reduced too much, well, we want to set this learning rate equal to this minimum learning rate. All right, and that was given in the hyperparameters. Good, so that's a good thing checked. Now we have to take care of early stopping. So to take care of this, we're going to get first our list of validation loss errors. And to this list, we're going to append the last average validation loss error that we just got. All right, and then we're going to check if this average validation loss error is lower than the minimum of all the validation loss errors that we appended in the list. And basically, that means that if we manage to get an average validation loss error that is lower than all the ones in the list, well, that means that there is improvement. And therefore, if that's the case, we're going to print, in quotes, the first thing the chatbot is going to say like a human, he's going to say, I speak better now, because he improved his ability to talk, right? So I speak better now. He's excited. And still, if that's the case, if we manage to reduce the validation loss error, well, we will reset the early stopping check variable to 0, because we increment it only when there is no improvement of the validation loss error, and we reset it to 0 whenever we find an improvement. And still, if we find a lower validation loss error, well, we want to save the model. And to save the model, we're going to get first a saver object that is going to be an object of the saver class taken from the train module taken from the TensorFlow library. So tf.train.saver here with some parentheses. So that creates my object. And then I'm going to take this saver object again, saver, and then use the save method that is going to take two arguments. First, our session, and second, our checkpoint, which contains the weight. Perfect. So that's all we need to do when we find a validation loss error that is lower than all the validation loss errors that we got so far. But then, if that doesn't happen, which we have to include in an else, and I'm going to scroll down here a little bit. So if that doesn't happen, meaning if we don't find a validation loss error that is lower than all the ones we've collected so far, well, in that case, our chatbot is going to have to say, sorry, I do not speak better, because I did not improve my ability to speak English. And we're going to make our chatbot ambitious. He's going to say, I need to practice more. He's going to practice more because early stopping has not stopped everything yet. All right, then, speaking of early stopping, since we were not able to find a validation loss error lower than all the ones we've collected so far, well, we have to increment the early stopping check variable. And therefore, I'm taking my early stopping check variable and I increment it by 1. And now that's where we need to check if this early stopping check variable has reached the final stop. That is the early stopping stop variable, which we set equal to 1000. And that's why I'm going to make an if condition here, a new one, checking if this early stopping check variable has reached the early stopping stop variable equal to 1000. And if that's the case, that's where we have to break everything. And we even need to stop the main for loop, and therefore we need to repeat that again, this if condition. So we have to paste it here, make sure you're at the right level. So if that's the case, what we're going to do is first we're going to print something new, and we're not only going to make our chatbot ambitious, but we're going to make it polite. He's going to say, my apologies, I cannot speak better anymore. This is the best I can do. So we have a very nice chatbot and we don't want to be too harsh with him. So this is the best I can do. And then we're going to break the whole thing by adding a new break here. And eventually we will print game over. And congratulations guys, you have completed part 3, training the chatbot. So let's scroll back up to see if we managed to see the whole thing. No, we can't. That was huge, as I told you. But that's okay, you can open it in a text editor. And I highly recommend to take a step back and see all the flow, all the logic of what we did here. And now, eventually, the moment we've all been waiting for, we are going to select this whole section to make this powerful brain that we made in part 2. We're going to make it smart right now. There we go. The training is launched. Let's fingers crossed it's going to work. I'm pretty excited, but at the same time pretty nervous. But there we go. It is working. Welcome guys to the first epoch with the first batch. And so there we are. The training is on its way. I'm super relieved that this huge for loop was executed without any issues. I was pretty nervous, but there we go. Now it is happening. It is on its way. However, the bad news is that it's going to take a huge amount of time. We're talking several days here, at least on my computer. So I'm going to leave that during Christmas, because actually right now it's almost Christmas. At the time I'm speaking, we are December 22nd. So I'm going to leave that during Christmas, but no worries, I have some good news for you until we wait for the results. So let's let this run, and I'll see you in the next tutorial in part 4, testing the chatbot, to implement the code that will test the chatbot, how you know we're going to interact with it, speak with it in the console, but then there's going to be another surprise. I'm going to give you one of the best chatbots implemented in the world. Until then, enjoy Deep NLP. Hi guys, welcome to part 4, testing the sec-to-sec model, and congratulations for having reached this far. Indeed, you built a brain, you trained the brain, and now you're about to chat with a chatbot. So congratulations, you did the most difficult part. So as you can see right now on my computer, the training is still going on. I just woke up after a good night's sleep, and as you can see, we've reached already the 3rd epoch, and I already got some weight that we can see here in File Explorer. So these are the first weights, and therefore these are not the weights of some very smart brain, or should I say of some brain with high abilities to speak with us. So we're gonna have to wait some more for some better weights, and on my computer unfortunately this is going to take a couple of days, but don't worry, we'll get them. And besides, in the meantime, I'll give you an awesome pre-trained chatbot, which is my favorite chatbot in the whole internet. So I will show you how to execute this chatbot and chat with it. But in the meantime, we're going to implement part 4 now to test the sec-to-sec model and basically implement a code that allows us to speak with the chatbot in the console. But as far as I'm concerned, I'm going to do that on another computer because I want to leave the training, do it things peacefully on this computer. So I'm going to jump now to my other computer. Welcome guys, and welcome again to part 4, testing the sec-to-sec model. So as you can see, I've transferred everything from the old computer on which the training is going to this computer, which is, by the way, my laptop. And so now we are going to implement part 4 that will allow us to chat with the chatbot with the weights that we got so far after a couple of hours of training. I remind that the results will be very poor because the chatbot needs to train a lot more to know how to speak, like this would be the case for a child learning how to speak. But you will know how to implement the code to chat with the chatbot, and besides, when we have better weights in a couple of days, well, we will load these weights, of course, in a flashlight to have a better chat with the chatbot. Alright, so we're going to start by actually loading these weights and running the session. And so to do that, I'm going to introduce the checkpoint variable, which is going to contain the path to these weights. And so the path is in the working directory folder, which is this folder right now. And in this folder, well, we need to get the chatbot underscore weights.ckpt. And that's it, you know? So only this part in the weights. You don't have to include the rest. So chatbot weights.ckpt. All right, so that's our checkpoint. And now what we're going to do is open a session. So introducing a new variable here, session, and I'm getting TensorFlow because this session is actually going to be an object of the interactive session class, which we already used. That was actually in the training. So now we have our session, and now what we're going to do is the same. You know, we take our session object and then use the run method from this object to initialize the global variables with TensorFlow.global variables initializer, this one, and with some parentheses. And then after that, that's where we will connect these loaded weights to the session. And to do this, we'll have to create a new object, this saver object, which we'll create by taking TensorFlow first, then the train module, and then the saver class. All right, so this is just an object of the saver class. And now that's where we connect the session to the checkpoint through the saver, because we're going to take our saver and then use the restore. It's like a load function, the restore method from the saver class to connect our session and our checkpoint. All right, and there we go. This way we load the weights. All right, and no need to execute anything right now. We'll execute everything in the end. So I'll see you in the next tutorial for the next step, which will be to make a function that will convert the sequences in string in the question to sequences of their encoding integers. We'll need to do that to set up the chat afterwards, which will be our last step. Until then, enjoy DeepNLP. Hi guys, and welcome to this new tutorial. In this one, we're going to make a function that will convert the questions that are right now in strings to lists of encoding integers. And why are we doing this? That's because we will need that function for this final step right after this tutorial to set up the chat between the chatbot and us. So let's make this function. We start with def. We're going to call that function convert, well, let's say string to int. And that function is going to take two arguments. The first one is the question, and the second one is word to int, which is a dictionary. So it can either be the question's words to int dictionary or the answer's words to int dictionary. All right, so these two arguments. And now let's define what it has to do. First, before making that conversion, we're going to clean everything in the question. And we have a nice function for that we made, which is the clean text function. So that's why I'm going to take my question, which is one of my arguments, and I'm going to clean it thanks to the clean text function. And of course, this clean text function takes the question as input. And now we can make the conversion. And to make that conversion, well, first we will return directly what we want to return, that is the question as a list of encoding integers. And therefore, since we want to return a list, I'm going to introduce here some square brackets, and I'm going to use this for loop inside a list trick that you know we've done several times in this course. So there we go, for, and we're going to loop over, of course, the word in the question. So for word in question, and then remember we need to add dot split with some parentheses to get the words separately. And so what are we going to do for each of the words in the question? Well, we are going to convert them, and for that we're going to use our word to int dictionary, but we're going to use a trick, which is the get function, because the problem is that we filtered out some words that were not frequent, among the least frequent words. We filtered them out, and therefore they do not exist in the dictionary, but they might exist in the question. And we're using this get here to make sure that if this non-frequent word is not found in the dictionary, well, the out token ID will be returned. Remember, we made an out token for each of these non-frequent words. And that's why in this get function, we're going to input first the word that we're dealing with right now. And if this word doesn't exist in the dictionary, well, we'll return the word to int dictionary of the key, which is the out token. All right, so that it returns the unique integer encoding the out token. Otherwise, it will get the unique integer ID encoding this word based on the mapping of this dictionary. All right, and that's it. That's just the function we had to make here. Congratulations, we are ready to set up the chat. So we'll do that in the next tutorial, and until then, enjoy DeepNLP. All right, let's set up the chat between us and the chatbot. So we're going to start with a while true, which will set the interaction between the chatbot and us until we apply the break. So we're going to start by getting the question we'll be asking to our chatbot. And this question, we'll get it by using the input function, which will take as input what we want to enter in the console when we ask a question to the chatbot. And therefore, I'm adding in quotes here, you, which will be you, yourself, with a colon and a space to separate you and your question. All right, so that's the first step. We get the question. Then we're directly gonna make that break to stop the interaction when we want to. And we are gonna stop the interaction when we say goodbye to the chatbot. That is when our question is goodbye. And therefore, I'm going to say now that if our question is equal to goodbye, like that, well, in that case, we're going to break. And this will stop this while loop. All right, then, now that we took care of this, we are going to take care of the real conversation between the chatbot and us. So the first thing we need to do is, now that we got our question that we enter in the console, we're going to do all the process of getting the question in the right format so that it can go into the neural network and so that we can get the predicted answer. And therefore, the first thing we need to do is, well, first update our question this way by using the convert string to int function that takes, as we defined here, the question and the question's word to int dictionary. All right, so that will convert the string of that question into the list of encoding integers. Great, so that's the first thing we must do. Then we need to apply the padding. We need to make sure that this question has the same length as the questions that were used for the training. And the questions that were used for the training, remember, have a length of 20. And therefore now we must complete the length of that question with enough path tokens, and more precisely path token IDs, so that this question has a length of 20. And to do this, we'll first take the question and update it this way by taking it again and then adding, since now our question is a list, we're going to do a list addition. We're going to add to our question list the following list, that is the list of the path tokens that need to be added so that our question has a length of 20. And to get this, you know the trick. We first take our question's word to int dictionary to get the unique integer encoding the path token. And therefore here I'm entering the key, which is the path token. And then we're going to multiply this list by the difference of 20 and the length of our question. And that will complete it exactly by the number of path token IDs that will make the question have a length of 20. All right, then next step. Now that we have the single question in the right format, well, remember the essential thing we need to do when working with neural networks, it's the fact that this question must be into a batch. The neural networks only accept batches of inputs. They only accept input batches. And since now this question is by itself, we need to put it into a batch. And we're actually going to create a fake batch which will contain this question and then some empty questions that will only get zeros. And that's why now I'm introducing this fake batch variable that I'm going to initialize as a numpy array of zeros. And in this zeros function, we need to specify the dimensions of this fake batch. And that's the only argument that has to be a couple of 2 elements. These 2 elements being the number of lines of this array and the number of columns of this array. So the number of lines is going to be, of course, the batch size, because each line corresponds to a question, and the number of columns is going to be, well, of course, 20, because our neural network was trained with questions of length 20. You can actually change that if you want. All right, so that initializes this fake batch, but then now we need to include our question in this fake batch, and to do this, we will simply include it in the first row of this fake batch, and therefore I'm setting this first row, that is fake batch of index 0, to be equal to that question. And now that we have our batch of input in the right format, well, we are ready to feed that into the neural network to get the predicted answer of the chatbot. That is the output of the neural network. And this predicted answer, to get it, we're going to use our session, then the run method, which will take 2 arguments. The first one is our test predictions variable that we made in part 2, building the sec-to-sec model. And then remember, the second argument is a dictionary of 2 sets of keys and values. The first one is the inputs, which are, of course, our batch of inputs, which we called fake batch. and then the keep probability that, remember, we set it equal to 0.5, 50%. All right, so that exactly will return a list of several elements, and the one that we're interested in, that is the predicted answer, is actually the first element of that list. And therefore we need to add here some square brackets and then inside the index 0 to get that first element. All right, perfect. And now that we get the predicted answer, well, we are ready to prepare the output we'll get in the console. So we could directly get this predicted answer, but we need to post-process it, if I may say. You know, we have the predicted answer, but we must turn it into a clean format, meaning that we'll replace, for example, all the lowercase I by capital I's. You know, when the chatbot is saying, for example, I am not, I do not, whatever. We will also replace all the EOS tokens by dot, because that corresponds to the end of a sentence and therefore it should be a dot. We'll replace all the out tokens that correspond to the filtered out words by simply out. And for the rest of the elements in that predicted answer, which I remind are the unique integers in the dictionary mapping the tokens to the integer IDs, well, we'll simply return the token associated to that unique integer plus a space, so that in the answer we can separate the different words by spaces. All right, so let's do this. Let's introduce the final answer with an empty string, like that. And then we're going to do a for loop to loop over. So here I'm going to use a trick, a numpy trick. So I'm getting numpy here. And then I'm going to use the arg max function that is going to take as argument our predicted answer and the axis, which is 1. And basically what this will do is get the token IDs in the predicted answer. So I'll provide the documentation for the argmax function by numpy, but what you need to understand here is that I is going to take the values of the different token IDs in the predicted answer. All right? And so now we're going to make the replacements I mentioned, starting with the lowercase I that we're going to replace by a capital I. So if the answers ints to word dictionary of key I, that is of key the unique integer ID in the predicted answer, is equal to lower I, well, in that case we're going to replace that by capital I, and therefore I'm going to introduce here a new variable token that will be equal to capital I. Then next thing we can catch and replace by something nicer. Well, first we have to use an elif. Same, we're going to take our answers ints to word dictionary. And so if the token we're dealing with right now is the end of string token, well, in that case we're going to replace that by a dot in quote. Perfect. Then I'm just going to copy this because this is going to be the same. All right, so this time what do we want to take care of? Well, we said the out token, and in that case, well, we said that the token is going to be out. All right, and that's it. That's the main things that we're going to replace. And we're going to finalize this with an else, meaning that if we get any other token, well, in that case, we will simply replace that token by a space plus that token we just got, which is answers ints to word of key I, which will return the token. All right, so we got all the conditions, and now we need to increment our answer, which so far is an empty string, by the token, and therefore I'm getting here my answer, incrementing it by the token. All right, so the different tokens in the predicted answer, cleaned by everything we did here, will be added one by one to the final answer we'll get in the console. Great. And finally, we need to add the very important last condition, which will end this for loop, and we will end it by a break. It's that if the token is a dot, well, that means that we've reached the end of the answer sequence because of this condition here. You know, the n is marked by the end of string, and we replace that by the dot. Therefore, if we get a dot, then that means that it's the end of the chatbot answer. And in that case, our chatbot is done talking. All right. And finally, let's not forget to print the chatbot answer. And to do this, we'll specify first that it's the chatbot speaking. So I'm adding chatbot here, then a colon, and then a space to separate this chatbot string by the answer of the chatbot. And speaking of the answer of the chatbot, that's exactly what we'll add here with plus answer, which is the answer we formed here by adding each of these different tokens we can get by going through the different tokens of the predicted answer. All right, perfect. So we're done with this code that will hopefully allow us to interact with the chatbot. And now, guys, congratulations. Not only you reached the end of the whole implementation, but also you are ready to interact with a chatbot. So now I'm just going to get a little less excited because remember, our chatbot was poorly trained. I just trained it while sleeping for a few hours. So the chatbot needs to be much more trained than that. And therefore, what we're about to get here will be a very poor conversation. I will actually just say one thing, you'll be convinced of the answer, and you'll be convinced that, of course, we need to train the chatbot more. And not only that, I will also try to improve the model. I will tweak the parameters. I will try to improve the data preprocessing. But I also encourage you to do that as well. You can provide your ideas and your implementations in this course so that we can together find the best chatbot. And speaking of the best chatbot, after this tutorial, I will show you the best one ever made on GitHub, and I'll show you how to execute it and chat with it in the next tutorial. But before we do that, I'm of course going to show you what you need to execute here to chat with the chatbot. Well, that's simple. That's basically everything except the training. All right, so we're simply going to execute everything from here up to the top. There we go. So it's going to take like 10 seconds, but we're going to get basically all the building of the model and all the data preprocessing variables that we made together. All right, and now there we go. We are ready to select this whole section, that is the whole code section of part 4, to interact with the chatbot. Are you ready? Let's do this. All right, so a few seconds, and there we go. You starting the conversation with the chatbot. So don't expect miracles. It was only trained for a few hours. It's gonna say total nonsense. But remember, I'm training the chatbot on my other computer during the whole Christmas holidays. Actually, I'm going on holidays tomorrow for Christmas, and my computer is gonna stay here spending Christmas with the chatbot. And after I come back, I should have some better weights. And of course, based on the results, I will try to improve the model. All right, so let's just say, for example, hi, and to get the chatbot answer, you just need to press enter. Oh my God. And our chatbot replied, kicked cases, ladies. I have no idea what this means, but as I told you, this doesn't make any sense. So I think we should stop here. I don't really feel like talking to the chatbot right now. So I'll see you in the next tutorial where I'll show you how to chat with this best chatbot. And besides, you have an amazing article explaining how the chatbot works. And of course, this is based on a sec-to-sec model with a lot of common things that we did in this implementation. So you will have no problem understanding this model if you want to choose it over mine. I won't be offended. My role here is just to explain how things work, but I'm not, of course, the best developer in the world. And that's why I'm very happy to show you the best implementations, the best chatbots by the best developers. So I'll see you in the next tutorial to show you this. And until then, enjoy DeepNLP.